Hey everyone, today we're going to be learning about least common multiples. So, firstly, we have some vocab words. Multiples are numbers you get when you multiply a given number by an integer. Common multiples, numbers that are shared multiples of a given set of numbers. Those are common multiples. And least common multiples, the smallest common multiple of a given set of numbers. So first method we're going to do is the listing method. The listing method is exactly what it sounds like. We're going to list the numbers, and we're just going to list multiples. So for 18, we're going to list the multiples of 18. We have 18, 36, 54, 72, 90, 108, and we're just going to take a break and start counting by 15s. We count by 15s. When we count by 15s, we have 15, 30, 45, 60, 75, and 90. And if we stop right there, we notice that our 90, that is the first common multiple. Therefore, because it's the first common multiple, it's also going to be the least common multiple. So my least common multiple is going to be 90. Next, we have the prime factorization method. So this is the method we learned yesterday in class. So we can break down 140. We can also break down 126. And I'm not going to use a factor tree for this. I'm just going to do it mentally. I know that 140, I could break that down into 2 times 70. And I could break 70 down into 7 times 10. And here I'm just listing the prime factors. So now all I have is 10. I could break 10 down into 2 times 7. 2 times 5. So that is my prime factorization for my least common multiple for my 140. And now let's do my prime factorization for 126. So if I break down 126, I could split that in half, and that would be 2 times 63. And if I split that in half, 2 times 63, 63, that is 9 and 7, so it would be 7 times 9. I can break down 9 into 2 groups of 3. Now, just like yesterday, when we were finding the GCF, right, we find our pairs. In this case, it's the 7 and the 2. So that's going to be our 2 times 7. We're going to list our pairs. And then we're just going to write everything else that's left over. That's going to be times 2, times 5, times 3, and times 3. And where I got that from was times 2 times 2, right? And there was a 5 left over and the 5 left over. A 3 left over and a 3 left over and a 3 left over. There you go. So the important part here is that we write down the pairs just once. Even though there's 2 7s, I only write it down once. And then I have to write down each individual prime factor that's left over. Now, in my opinion, the easiest method, this is going to be the ladder method. When we do the ladder method, we can take it and write 168, 216. Now I see that these are both even. So what I'm thinking is, hey, if they're both even, let's do 2 right away. If I do 2 right away, half of 168, that's going to be 84. Half of 216, that's going to be 108. I could do 2 again. And that would be 42 and 54. And then now I see that these, I'm thinking what goes into both of them? 6. Hey, 6 goes into both of them. So 6 goes into both of these. 6 goes into 42 7 times. 6 goes into 54 9 times. So for this, what we're going to do is this makes an L. So this whole thing is going to be my LCM. Let's see if it makes a nice L when I hold it. Yeah, so that makes an L. So that whole thing is going to be my LCM. So basically, your left side is your GCF. So it's going to be all of this. So your LCM is going to be 2 times 2 times 6. And then we're going to be multiplying times the 7 that's left over. Oh, that's not my highlighter. Times the 7 that's left over, times the 9 that's left over. And then when I'm done multiplying all this out, well, we can multiply it in bits and pieces. All right, we know that this right here is going to equal 24. 24 times 7 times 9. And I'll save you the work. Feel free to hit pause. That is going to equal 1,512. So my LCM is equal to 1,512. Again, for LCM, when you do the ladder method, once it's broken down all the way, you can just multiply all the outside numbers together. And I mean, hopefully it doesn't give you a 4-digit number, but it's okay. We know how to handle that. So we're going to find the LCM between two numbers. My favorite way is the ladder method, so let's use ladder. So when we have the 84 and 28, I'm thinking, hey, what goes into both of these? And I'm thinking, hey, 2 right away goes into both of these. And we get 42 and 14. Now, again, I'm thinking what goes into both of these. I see right away that it's going to be a 14. 14 goes into both of these. And if you didn't see 14 right away, that's fine. You could have said, like, hey, 2 again, and then you would have ended up with 7. That all works. So 14 goes into 42 3 times. And 14 goes into 14 1 time. And then my LCM is going to be everything that is on the outside. So my LCM is going to be 2 times 14 times 3 times 1. And 2 times 14 times 3 times 1. My LCM is going to equal 84. And that just makes sense, right? If I start counting by 28, I would get 56. And then I would come up with 84. And using the listing method, we know that the LCM would be 84. So 45 and 28. 45 and 28 is a word that we call relatively prime. We learned that already. They do not share any common factors besides the number 1. So if that's the case, we can't reduce it at all. So all we end up doing is we end up multiplying. We take the 1 times the 45 times the 28. And when we multiply this, the LCM is going to equal 1,260. Again, I saved you the work. If you did 45 times 28, you would have got the same exact thing. So for this next one is going to be fun. With 3 numbers, my opinion is it's easiest to do the listing method. You can also use ladder method for this. I'm going to teach you both. Feel free to not remember the ladder method. Feel free to just instantly forget it. And because it can be confusing. So if we're counting by 60s, 60, well, we'll use 60 as our first group, and then 120, and 180, and then 240, and then 300. Let's count by 90s. 90, 180. Hey, I already see a pair there. 270, 360, 450, and 45. Then we end up with 90, 135, 180. Hey, look, right there. Automatically, our LCM is going to be 180. And if you want to stop there, go ahead. Feel free to skip this next part. If you want to do it with the ladder method, I will show you. So for ladder, let's use black. We have 60, 90, and 45. We break this down. I think we might all be able to see that a 15 goes into each one of these right away. 15 goes into 60 4 times. 15 goes into 90 6 times. And 15 goes into 45 3 times. But if we multiply all these out right now, this is automatically 60 right here. And then if I multiply that, that's 360. And we're already getting way too big. We know our LCM needs to be 180. So with this method, then this is the part that makes it confusing. If any of these numbers share a factor, you can also reduce it. But even if it's only 2 out of the 3. So with the 4, 6, and the 3, I see that I can take we will say a 2 out, but I can't take a 2 out of everything. I could just take a 2 out of this 4 and a 2 out of this 6. And if I do, I am left with 2, 3, and 3. And now I see that I can reduce the 3 and the 3s. If I do, I'm going to be left with, or what can I take out of these 3 and these 3s? This would be a 3. When I take this 3 out, then I'm left with a 2, a 1, and a 1. Now, these don't share any more factors because these 2 1s I can't break down anymore. So now if I find the LCM of this, then it will make sense. We'll come up with the 180. 15 times 2, that is going to be equal to 30. I wish I could make that smaller. And then 30 times 3 is going to be 90. And then 90 times 2 is 180. And again, I fully anticipate this way to be confusing, so feel free to only use the listing method. Next one. This is like finding the GCF, sort of. So let me explain the thought process behind here. We know that the greatest common factor for here, we can break this down. We have 54. Let's just use the values right now. Let's just use the numerical values and not the letters. I see that I can take a 9 out. I get 6 and a 4, and then I can take a 2 out. And then I get 3 and a 2. Now, my numerical value is going to be 9 times 2 times 3 times 2. So my numerical value, 9 times 2 is 18, times 3 times 2, that's going to end up with a 108. And just how, like, last time we took out factors, like if I was taking out factors yesterday, I could only take out an a cubed out of each one of these because that is the variable with that share the same term. Like they both share a third, they don't both share to the 4th power. All right? And this is also called to the degree. You can also use the word degree for the exponents on a variable. So that's a to the 4th degree, b to the 2nd, and a to the 3rd. For finding LCM, we just take the highest degree of each letter, and we just rewrite it right next to our LCM. So the highest degree, so I have two A's here. One degree is to the fourth, and the other degree is to the third. So the degree I'm going to use is to the fourth, so that's going to be A to the fourth. And then we have B to the second. We only have one B to the second. But right here, technically, we have a B to the 0. B to the 0, because B to the 0 is going to equal 1. So technically, we also have a C to the 0 and a D to the 0. We have all those. So let's just get rid of all this. So my highest B term, my highest B degree is going to be B to the second. So mathematically, I found out my numerical number right here. And then each of the variables, it's whatever variable was in the problem with the highest degree. So now comes the tricky part. So first we're going to simplify when we're going to add these fractions up. We're going to simplify first. And when we simplify, we're going to take out all the common factors, just like we did yesterday when we were adding these. So we're going to simplify first. So yesterday we learned that, hey, 7 and 10, they don't share, they're relatively prime, so I can rewrite my fraction with the 7 over 10. I know that I can cancel out x squared out of both of these, and I'm left with just x to the third on the bottom because my denominator has more x's in it than my numerator. And then my y, I would end up with one more y in my numerator. Let's take this out. And then if I plus here, we can simplify the next one. So 3 and 8, they do not reduce. My x squared and my x cubed, I have an x in my denominator. And then my y and my y to the 6th power, I would have 5 more y's, or y to the 5th power, in my denominator. So now, if this is a fraction, this is where the LCM comes from. We need to find the least common multiple. And you may be thinking like, hey, this doesn't make sense right now. Well, it's the same premise as if I had 1/2, can I add it to, I don't know, 3/10? Well, yeah, we would change, well, let's change, whoopsies. Let's not worry about that. All right, 3/10. Well, I would need to change this term, and I would need to make it 5 times bigger in the numerator and 5 times bigger in the denominator, so that way they had the same denominator. So what we're doing is we need to find the LCM. So what do I need to find the LCM of? I need to find the LCM. Why is it not giving me colors? Of each one of these. So when I find the LCM, I'm going to rewrite it. I have 10x to the third, and I have 8xy to the 5th. Now I'm thinking, hey, what can I take out of this? I could take a 2x out of both of these. And again, just in case we forgot where they came from, we have that right there and this right here. So I can take a 2x out. And if I do take a 2x out, I'm going to be left with 5x squared. And I'm going to be left with 4y to the 5th. Now, when I have that, my LCM is going to be everything multiplied together. So my LCM is going to be, LCM, it's going to be 40x cubed y to the fifth, which means I'm going to turn this into that, and I'm also going to turn this into that. That's both of those denominators are going to be my LCM. So how am I going to do that? Well, I'm going to multiply this piece right here by this piece. Then I'm going to multiply this piece right here by this piece. So I need to multiply the side with 10x to the third by 4y to the fifth. I need to do that to the top and the bottom, the numerator and denominator. And on this side, I'm going to need to multiply by 5x squared. So when I multiply that, we're going to be left with 28y to the 6. Because here, let's highlight real quick. Here I have 5, here I have a 1, so that's going to make a 6. My denominator is going to be 40x cubed to y to the fifth. And again, it's 10 times 4, which is 40. X cubed times y to the fifth. I'm going to add that to 3 times 5x squared is just going to be 15x squared over. My LCM will be the same because it has to be the same if I'm going to add this up. It would be 40x cubed y to the fifth. And by doing that, I can combine these and we get the super anticlimactic answer of duplicate 28y to the 6 plus 15x squared. That's it. This is an application-based problem that just goes to show you how you can use GCF and LCM. I fully anticipate this to be difficult, and that's okay. So let's try to speed run this last problem. So first step is to simplify. And in order to simplify, you're just going to simplify each side again. So for the left-hand fractional value, we're going to be left with 7, 12. My A's are going to cancel. I'm going to end up with 3 on the bottom. My B's are going to cancel. I'm going to end up with 1 on the top because there's a 1 here. So there will be 1 in the numerator. My 4 and my 9 are going to stay the same. 4 and my 9. My A's, I have 2 more in my denominator, so that's what I'm going to keep. 2 in the denominator. I have no B's in my numerator, so B to the 4th. Once we find that, we now need to find the LCM. LCM of what, you may be asking? LCM of these. So we're going to write 12a to the 3rd. Then we're going to write 9a squared b to the 4th. We can see that automatically we can take out a 3 out of both of those. And then there's an a squared in both of those. And there's no b. So that's fine. If I take out a 3a squared out of this, I am just left with 4a. If I take a 3a squared out of 9a squared b to the 4th, I am going to be left with just 3b to the 4th. And now my LCM is going to be all of this multiplied together. So all together, my LCM is going to be 3 times 4 times 3, which will be 36. I would have 3 A's here. Again, I have 2 here and 1 here, so that's 3. And then I have 4 B's. So that is what my LCM is going to be. So I know that my LCM for both of these will be 36A cubed b to the 4th. And I'm going to minus 36, again, same denominator, a cubed b to the 4th. And if we remember how to, or what to multiply these denominators by, right, we're just going to be multiplying it by the opposite. So that was here, right, which is here. So I'm going to be multiplying it by the opposite, which is just right here. So I'm multiplying both of these terms by 3b to the 4th. I'm going to be multiplying this term by this, just times 4a. So when we take this, we're going to be left with 21b to the 5th. Let me keep that same highlighter for you. Does that look like a 6? I got to do that again. B to the, I said 5th, right? B to the 5th. And then, wrong color. Got to get back to my highlighter. And then when we go back to here, 4 times 4a, that's just going to be 16a. And we can't actually subtract those. So we're just going to be left with a final answer of 21b to the 5th minus 16a all over 36a cubed b to the 4th. And that is how you do that. All right, guys. Have a good one.